Hello once again, math enthusiasts. We finished off part A in the last 6 videos, the last 6 videos sort of constituted part A of the 2012 Csmc paper, that's the Canadian senior paper, for 11th and 12th grade level education. But of course, if you're at a younger grade, you're welcome to write it. So we're going to be looking now in the next 3 videos at part B, so that's the written justification portion. We're actually going to have to explain all our ideas if we want to get full marks and get complete answers. So let's take a look at the first question in part B. Alright, so question 1. In each diagram shown in this problem, the number on the line connecting the 2 circles is the sum of the 2 numbers in these circles. An example of a completed diagram is shown to the right. So inside the circles we have 5, 9, and -2. And on the line connecting these two, we have, so -2 plus 5 is 3, 5 plus 9 is 14, and -2 plus 9 is 7. Okay, so the line is the sum of the 2 circle spots. Doesn't seem that tricky of a concept. Okay, question A, so the actual question part of this thing. What is the value of x? I assume they're referring to this diagram right here. Okay, so x will be the sum of what's in this circle and this circle, so it'll be something plus 4. Now we're given the other 2 numbers, 10 and 13, so 13 here means that 13's got to be 4 plus whatever's in here. So that'll be a 9. And then we should be able to get the number in the bottom circle next. But we need to write out full solutions. So it'd be nice if we had names for these guys to manipulate them. So we'll call them Y and Z, and we'll say let Y and Z be as shown. So just referring to this diagram that we've drawn in here. So we know 13 is going to be equal to 4 plus Y. So y is going to be 13 minus 4. It's basic arithmetic manipulation. Then we get a 9 here. We know 10 is equal to y plus z. Okay, well we know what y is. So that's 9 plus z. So z is 10 minus 9, which is equal to 1. And lastly, we know x is equal to 4 plus z. But we just figured out what z is. So it's 4 plus 1, which is equal to 5. And that's our final answer for A part. Nice, simple, introducing us to the concept of the triangle summing bubble thing. Okay. And if we wanted to, we could write those numbers in and just double check, but fairly confident. A part is fairly simple usually. Alright, B. With justification, determine the value of y. So they're referring to this diagram over here. So we're given a 3w, we're given w, and we know that this sum and this sum are going to be the same. And we have this bubble not quite filled in. Okay. So since both of these sum up to y and both of these sum up to y, and they have a common w, we should be able to tell that this is 3w. And from there, we should be able to use that 48 to solve the question. (3w), 48, I will call this guy Z. I'll say let Z be as shown. Alright, so from this side we know that 3w plus w is going to be equal to y. That's just the definition of how the numbers on the line work. So y is really just 4w. If we can figure out what w is, we're home free. So we know that y is also going to be w plus z. We can rearrange that equation and say z is y minus w. Well, we have an expression for y in terms of w. It's 4w. 4w minus w is 3w. (48) is 3w plus z, but we know that z is 3w as well. So 48 is actually 6w. Thus w is going to be 48 divided by 6, which is 8. Y is going to be 4w. That was the first thing we figured out. Well, we know what w is. It's 8. So y is 32. Not a whole lot of written explanation there, but our steps are clearly laid out, and our final answer has been highlighted in some sense. You can put a box around it. Sometimes I like to underline things. If you're a little worried that you're not going to get full marks, you could explain, but the diagram is fairly self-explanatory. But if you want to, you could use different colored pens and say, oh, we're talking about this line here and this sum, and then use a different colored pen and talk about this sum, if you wanted to, if you thought it wasn't clear enough. But it's basically just straight arithmetic and algebra, really. So hopefully the next part is a little more difficult. We are in the written portion style questions, so they should be a little harder. Okay, C part. With justification, determine the values of P, Q, and R. Alright, here we go. So we have something a little harder. All we know are the sums. So we know that P plus Q is 18. And we know that P plus R is 3. And we know that Q plus R is 13. Okay. So I can think of a couple ways to do this. I'll do the most naive, but maybe I'll do the other one as well. So we have P, Q, and R. I think. Actually, do I have the order wrong already? Yes, I do. Q's at the bottom. So we must correct this. Otherwise, we will get a wrong answer. We have a 3 at the top, an 18, and a 13, but we'll just double check because I don't want to make any more errors. Okay, we're good to go. So, what we should probably do is just pick one of these variables to try and eliminate. Okay? We know that P plus R is equal to 3, so R is equal to 3 minus P. Okay? But we also know that Q plus R is equal to 13, so R is 13 minus Q. So we know that 3 minus P is going to be equal to 13 minus Q. We can rearrange these guys and get sort of a relationship between P and Q. Bring the Q over to the other side and the 3 over to this side. So we know that Q and P are going to differ by 10. Or really, we can bring the P over to the other side as well and say that Q is P plus 10. So now we know that 18 is P plus Q, So that's P plus 10. Rearranging this equation, we get that 2p is 8, or p is 8 divided by 2. 2 p's make up 8, so a half of 8 should be equal to p. So p is equal to 4. Q we know is equal to p plus 10. So that solves for Q. And R we know is 3 minus P. So 3 minus 4 is negative 1. So P, Q, and R, that's just 4, 14, and negative 1. So that's one way to do it. So another way to do it would be to say we know the sums of each of these, so we can add up all three equations. We get 2p plus 2q plus 2r is equal to 3 plus 18 plus 13. So that should be 34. Okay. So P plus Q plus R would be 34 divided by 2, which is 17. And for example, R is P plus Q plus R, subtract P plus Q. So that's going to be 17 minus 18 equals negative 1. Q would be P plus Q plus R, which we know, minus P plus R, getting rid of the other two variables. So that's 17 minus 3, 14. And finally, P, well, if we have P plus Q plus R and we want to just isolate P, we need to get rid of that Q and that R. 17 minus 13, that's 4. So in another way, we can do it. You can judge which method is better for you. It doesn't really matter. This one works because of the symmetry of the whole thing. We have P plus R, we have P plus Q, and we have Q plus R. So we have all possible combinations of adding up two different terms. So if we add up the whole thing, we'll have 2 copies of each term and a total value there. These only have 3 lines. Now, if you're doing this contest and you come up with 2 different ways of doing the question, pick the one that you think looks coolest, looks most elegant, and that you have the most confidence in. Do not write 2 different ways to do a final answer. You will only end up confusing the markers. They will think that you don't quite know you solved the problem at the end of your first way to do it, unless things are clearly marked. And otherwise, they might just think you're kind of arrogant, adding in different ways of doing things. So I would pick one way that you have the most confidence in, or one that you think looks really cool, because you're marked on clarity, completeness, and style. So if you have clarity and completeness with both solutions, pick the one that's more stylish. But either way, that was C part. There's no D part to question number 1, so that concludes the first question in the B portion of the 2013 paper. It's been wonderful having you guys here. I hope you've enjoyed the video. If you have, then hopefully you'll join me in the next question number 2. I'll see you guys then.